Welcome to our website for Techos Siglo XXI in Escazú, Costa Rica. Today we're going to basically go through our architectural standards. Now you may have been wandering around our site, or you may have actually seen an ad discussing $60 a square feet construction or $650 a square meter. At any rate, any of those numbers are totally irrelevant if one does not know what is it for. You must know what you're getting for your money. At any rate, so today we're going to go through our minimum architectural standards. This is just basically where we start with the quality of someone's home. Now this can be adjusted upwards, it just doesn't go down anymore. This is as basically as economical as we build. I on occasion get people wanting lower prices, and fundamentally any lower price means you're literally looking at a tin shack. Sorry, we don't build tin shacks. So this is where we start at, and there's basically two ways to build with is a contract to lock up, which is generally around $40 a square foot, and a complete to the home project at $60 a square foot. Doesn't really matter to us, and some people want to build in phases. They may take it to lock up and then come back a year later when they have some more money together to finish the interior of their house, or they may want to do it themselves, whatever. It's not particularly important. What is important is once you shovel goes into the ground, you do not stop until you're at lockup. That's a good idea anywhere, and it's most certainly is a good idea in Costa Rica, basically to secure the property. But anyways, we'll continue on, and we're going to go through a whole list of building materials so you've got a good idea as to what is involved at that price range. I know without question we're very economical in the market, but let's not confuse that. We do not build cheap houses. We don't use junk in our homes, and there's a lot of modern products I will not touch whatsoever. And in Costa Rica, we don't really have to, because many finer and older way of doing things are actually quite economical, and it doesn't require the use of tons of plastic. You know, plastic has a few limited places, but for general finishes, no. Anyway, and also very important to discuss is how we contract a home. This is basically cost plus contracting. So, for example, we go through an entire house and spreadsheet and list off all of the material items that go into a home, all of the labor that's going to go into a home, all of the fees as well. Of course, our fee for building the home is all there in a clear, concise form with an accurate budget that basically is self-determined. Meaning that if we put in a budget, there's $1,500 for electrical lighting, and you spend $1,000, you get a $500 credit. If we budget $1,500 and you spend $2,500, then you're going to have to put in another $1,000. So that's basically self-determination, and that mostly comes in the finishing stages, not in basic construction, unless at a last moment somebody changes the size of a house or something like that, which we have had done, but I mean obviously it's reflected in the price. Anyways, that's how the type of contracting we do. The issue is total transparency from start to finish, which is important to most people, and certainly important to us to be transparent with our clients. So we will start off basically going through a list of about 15 important areas of a home, and this is also in print format on the website, but I was going to go through this basically item by item and demonstrate some of the products. First of all, we're going to start with the walls. This is our sit panel. That is how it would look outside with an acrylic stucco in two different colors and two different textures applied to the outside of a sit panel. And then turning over on the inside, that's just basically a standard drywall process, just a tape put on between panels and mud and painted. Now, in the panel itself, this is showing like two panels side by side where they come together, and there's a spline put in here, and this is all glued together with a special caulking adhesive sealant combination specifically made for sets or structural insulated panels. There's very few screws, just enough screws to hold that together while it sets, and then the rest of the idea is to make a monolithic wall, a wall that moves in unison, and so if the ground is flexing under earthquake conditions or extreme winds or something like that, the wall has the ability to flex, and of course what's connecting the panels together, this special adhesive, flex 275% without a fracture, so very important. Now this has an insulation factor with all the styrofoam in it. This is also what it needs to make it structurally sound, and we use all this for all the interior walls as well. Anyways, that's is what our walls are constructed of. That is the structure as well as what supports the roof, obviously. Okay, for floors, on grade floors are concrete when that is the only option. Now, it's not really our recommendation. It depends on the building site. In fact, if the building site is quite out of level, it's actually cheaper to build a different style of floor. Because once you start hauling in fill or doing a lot of land movement, that drives up your costs significantly. And we are not lovers of concrete. We use it sparingly, as little as possible. In a house itself, the floor would be the only thing it would ever be used for, and that's a ground level floor. Once you go to a second story floor, then it's completely crazy. Because once you elevate concrete, the price goes up over double. And it's actually cheaper to use our other systems, lightweight systems, than it is to use concrete. Once it's elevated, it's completely out of the question. But anyways, if it's used, that's a standard 4-inch floor with 3,500 pound concrete in it, and of course reinforced with rebar around the perimeter, and all floors, of course, need to have mesh put in them, which often I've seen it missed out, and of course there's nothing to stop the floor from shifting, cracking, and shifting after it's cracking. Which is very easy to do in a seismically active country. Foundations, generally it's site conditions that dictate what this is, the soil studies, and you cannot get a building permit without a soil study, so that's what dictates what has to be done in your particular location. Now we're going to be using, definitely on steep conditions, we're leaning towards a product called ramjack, which is basically a big screw that goes into the ground and anchors into the ground. In essence, it's similar to pilings, but it's different, and it's much easier to get access to difficult locations, because you just can't go on the side of the mountain and try to put pilings in. It's not easy because of the boring rigs that would be required to do that. So this is a preferred in that situation if you have a very steep building site, and we have one coming up that's about a 35-degree slope. And so we're going to be using the ramjack system for that, and they're one of the best known in the world for structural foundation situations like that and resolving problems. Now for our elevated floors, which is what we tend to be leaning people towards that direction, for the comfort factor as much as anything. And now we're using a laminated beam. This is acacia. Let's get a nice good close-up of it there so that you can see it. It's all laminated. This is a plantation grown wood, and which is very critical in that it's a green product, and because we're laminating it, we do not need big dimensions, so that we can use much smaller trees, because a 2x6 normally needs to come from a very large tree, hence old tree, hence expensive tree, and typically not available in the plantation inventory. So in particular, what I like about laminated beams is they come straight and they stay straight. They install straight and they stay straight. 6 months, 66 years later, they're straight. And we happen to think they look very good. And also acacia is extremely bug resistant. Generally speaking, termites do not like to eat this stuff. We've had no trouble in the history, and this is made out of trees that are a mere 8 to 10 years old. Now we'll use this in a joist system for an elevated floor, also going up to a rafter to use as rafters as well. And we also use them in our wall systems. Here's another laminated piece of wood here. This is a 2x3 that basically goes into the track system and the corners and connectors used in the SIP structure, and so this gets glued inside the wall. This is completely hidden, but this is a structure out of sight, out of mind, but it's what basically keeps all your walls together. But again, a laminated wood because of the strength that offers, and the strength and the straightness of how it stays together. Now, we've been promoting to our clients to go with the elevated floors, particularly for the comfort factor. The concrete floors are extremely unfriendly on knees, backs, and a lot of our clients are not young people, so therefore, and everybody's getting older, unavoidable. So this is a much kinder floor, it's a drier floor, easier to put in, especially in uneven ground situations. It's actually cheaper than concrete, and just generally provides a much higher quality that you can use on that. And then we typically take the same MgO, magnesium oxide board, and sheet those floors with to put the finish on. Now, that would be, a typical floor finish is going to be, everything we cost out is with a porcelain. Now the significance with porcelain is two things. It's 3 levels on the Rockwell scale, harder than standard ceramic. So its life expectancy is much longer and the likelihood of damage is much less because it's simply much harder. But very importantly, you can see this is actually a cutting that came from the floor I'm standing on. And you can see how it is colored all the way through. So if it gets a chip or a crack, you don't see it like it would be a ceramic that would jump out in it. Now this will be put on top of a magnesium oxide board, which would basically be your floor sheeting, would be, in essence, this is just the magnesium oxide in this particular example here, but much thicker than this. There's a special flooring board that is in our container on our way to us at this moment that would go underneath those. Now, for those who want and prefer a wood floor, then there is no need for any sheeting, and we can use, here's an exotic Costa Rican wood. This is called tamarindo. That's in particular, this is a very beautiful floor, quite dense and hard. And this is a sample of corteza, or we would know it as ironwood. This was a parquet example of that, but extremely hard to, hence why it's called ironwood. But there is beautiful Costa Rican hardwoods that can go on the floor, and those can simply lay right over top of the joist. There's no sheeting at all, and highly recommended that there not be any sheeting used whatsoever. But wherever there's going to be tile, we basically put down the MgO tongue and groove paneling, and then put whatever tile finish is going to go on top of that. A lot of people here think you cannot do that, but that is nonsense. It's done all over Canada. All of our second-story floors are all out of a wood structure, hence we do that. Anyway, moving on. That's floor finishes. Okay, we discussed the roof structure already. So basically, that is going to be the wood rafters are going to go up, and then on top of that wood rafter here, we would basically put what is known here as tablilla. This would go on top of it. So from underneath, you will look up and you will see an entire wood ceiling. This is our preferred method in which to do this, and it looks like $1 million.